the objective of today's presentation is mostly towards resolving your queries related to our new program, which is electrical and computer engineering. So I am joined by a few professors in the meeting also. We do have Dr. Upendra, who is a nanoelectronics scientist with us. He's an assistant professor with us. So he will also be joining in case you have any queries related to this new program. Uh, so as we decided, we are not going to focus about anything on Shiv Nadar University or something, but our focus is to resolve or explain to you how this electrical and computer engineering program will be helpful for your kid in future. And also the main objective here is to differentiate how this is different from the existing computer science engineering program. So that's the objective of this presentation. I'll just give you a brief note about first the department so that you know how rich the department is before you take on your decisions to admit your kid in the department. So we are an electrical engineering department here. When we say electrical engineering, it has electrical, electronics, communication, and now computer engineering also. Please remember that I will be differentiating the difference between computer engineering and computer science engineering later on towards as we proceed. Currently, our faculty strength is 18. We have 6 professors with us, 6 associate professors with us, and 7 assistant professors with us. We have close to 9 lab technicians, 1 executive assistant, close to 23 active PhD students here. And this is one of the largest departments. You can see there are more than 400 students in this particular department. And these are some of the qualifications of the faculty that I have listed. Professor Dinkar Prasad is the head of the department from IIT Kharagpur. And then Professor Madan Gopal, he is ex-faculty IIT Delhi. Any electrical engineering graduate must know Professor Gopal because of his textbook on control systems. And then we have Professor MP Dave, who is also an ex-faculty from IIT Roorkee. We have Professor PC Jain, who is from Siri Pilani and CDAC. He was the director of CDAC. Professor Vijay Chakka, he is professor from NIT Trichy. And me myself, I am the UG advisor for this program also. And after the student gets into the department, any queries related to the academics, I will be the contact person. And then we do have Professor Amitabh Chatterjee from University of California, Dr. Venkat Hariharan from IIT Bombay, Dr. Sonal Singhal from IIT Roorkee. So she will be the UG advisor for first years. Professor Atul Veer Singh from IIT Delhi, Dr. Madhur Upadhyay from IIT Delhi, Amit Bakshi from IIT Bombay, he is the UG advisor for the existing EEE programs. And then Professor Himanshu Sahu from IIT Guwahati, Akash Sinha, he is a robotics specialist from Carnegie Mellon University. Dr. Jitendra Prasad from IIT Guwahati, Dr. Upendra Pandey, who is with us from Italy, Dr. Rohit Singh from IIT Indore, and Dr. Kamal Singh from IIT Bombay. So you can see the richness of experiences of all our faculties here. And just to give you a glimpse, I have just taken the same pictures from the photographs also in case you want to relate with the photographs. Dr. Dinkar Prasad, our head of the department. Professor Suni Tuli is the Dean of Partnerships, Dean of Research, and Dean of Accreditations and Ranking. Professor Vijay Chakka and me, myself, Naveen. Dr. Venkat Hariharan here, Amitabh, Dr. Atul, Sonal, Madhur, Amit Bakshi, Himanshu, and Jitendra Prasad, Prajapati, Dr. Upendra, Dr. Rohit Singh, Kamal Singh, and Akash Sinha. These are our visiting professors just I introduced. So to start with, this electrical department, though this is the largest department with huge number of students, our focus is largely towards research also. And we work in areas of signal processing, microwave engineering, microelectronics. Microelectronics include VLSI and nanoelectronics. and organic electronics, which includes the organic flexible materials in electrical solar systems. Then communication engineering, power systems, machine learning, power electronics, and machine drives. You can see here that all areas of electronics, communications, and the power engineering are distributed. So, and as I said, this is one of the most largest department with so many labs also. We have machines lab, we have electrical machines lab, control systems and instrumentation lab, power system simulation lab, and each lab is of a square feet of 2000 square feet, which can accommodate close even to 60 students in one go. Power electronics, electronics lab 1 and lab 2, these are dedicated to the undergraduate teaching for large section of courses. Microwave engineering lab, communication engineering lab, digital signal processing lab, embedded and robotics lab, VLSI and microelectronics, project lab, nanoelectronics and computation lab. This is a dedicated research lab that we have here, and organic flexible electronics lab. So the last two are dedicated research labs we have. Now, if you look at the academic program, we started in the year, we are the first department to be started when the university started. We started in 2011. So right now we have crossed more than 11 years of our operation, and we offer BTech program in electrical and electronics and communication engineering. Shortly we call it as ECE, which we started, which is a 4-year program which we started in 2011, and the ECE program will continue till 2025 only. Similarly, BTech in electrical and electronics engineering, which is also a 4-year program. Shortly, we call it as a EEE program, which will also continue till 2025. In other sense, we are not admitting any students from the next academic year for these two programs, BTech ECE and BTech EEE. Instead, we are starting a new program, BTech in electrical and computer engineering program, which is also a 4-year program. We are, for the first time, we are starting from 2022. I will explain why we are doing away with ECE and EEE and why we are starting with electrical and computer engineering as we proceed in the presentations. So these are the areas of research that we offer for PhD programs also. In addition to undergraduate, we don't have a master's program, but we do have a PhD program. So any student, a bright undergraduate student, if he is interested, he can also get into the PhD program also. So these are the areas of PhD we admit students: electrical machine drives, power electronics drives, microwave engineering, MEMS technologies, microelectronics and mechanical systems, material sciences, signal processing, and wireless communications. These are very broad areas of work. And to be precise, so far we have awarded 11 PhD scholars from different these areas. So we did have an MTech program also. We had a tie-up with ST Microelectronics, and we ran this MTech program for 2 years. Since we did not get quality students in MTech, we stopped admitting students there. Currently, from our department so far, 785 BTech students have already graduated. And currently there are close to 400 students who are already with us for the 4-year programs. So just to give you a snapshot of the important point of contacts in case you want to discuss anything further related to the department. Professor Dinkar Prasad is the head of the department. Dr. Atul Veer Singh is the PhD coordinator. And myself, Dr. Amit Bakshi, are the undergraduate advisors. And Dr. Sonal Singhal, who will be looking after only the first-year students. Now, I'm slowly starting to explain the importance of electrical and computer engineering. When we had till 2022, till last year, we had these 3 specializations. As a department of electrical engineering, we had electrical, electronics, and communication. This electrical plus electronics, which is what is this EEE program is. This electronics and communication, which is what is this ECE program. We realized having so much years of experience and with our broad experience abroad also, that all our courses employ some kind of computers in our programs. So what we decided was, in order to give more emphasis with regard to the future research also, and with regarding to our peer universities abroad, we decided that computer engineering cannot be discarded going forward. Hence, what we decided is to include computer engineering concepts also. So what we decided is to have all electrical, electronics, communication, and computer engineering. We are coming up with a new program called as the ECE program. Now you might realize there are multiple questions that might come. How is this different from the existing computer science program? I will explain you first with what we are doing now, that is existing programs of EEE and ECE. I will give you a complete overview, and then what I'll do is I'll compare this ECE and computer science engineering program. I will compare so that you can relate what has been in the past and what is going to be in the future also. So to start with, if you look at our electrical and electronics engineering program, which we shortly call it as the EEE program, the specializations were power engineering, electric drives, power electronics, and energy engineering. These are the 4 different areas of specializations of EEE program. Currently, what we are doing, not about the new program. With related to ECE, I mean, the pictures, whatever you see are our electrical engineering labs only. And with related to ECE program, we are specialized in VLSI, embedded systems, IoT, signals and systems, and microwave engineering. These are our actual pictures from our labs. Now, in order to give you what we are doing currently and why we are not going to do these things going forward, lies in our curricula actually. Now, this is the EEE curricula. What you see on this side is the EEE curricula, and what you see on this side is the ECE curricula. So our curricula, our students for EEE program must earn 162 credits, and for ECE program they must earn 160 credits. And there has been we have divided our courses into these types, that is CCC course, UWE course. You are already aware about what is an UWE course is. If you want to earn a minor degree, then you have to choose 18 credits so that you can earn a minor degree. So combined, you must have 42 credits for you to be eligible for a BTech degree in EEE or in ECE. So both these structures are same. Since we are into electrical department, almost most of the structure will be very, very similar, except few changes here. Basic sciences, there are 20 credits in both the cases. Engineering sciences also 12 credits in both the cases. The only difference is the major core course, there is 61 credits that is required, whereas it is 59 credits that is required here. Whereas otherwise, the major elective, major projects, they are all the same. So this is about the current architecture for curricular architecture for EEE and ECE programs. Still, I have not started explaining the new program. Now, I've just listed the courses so that my flow will be towards our electrical and computer engineering program. So this is the first year course for EEE. This is the first semester course for ECE also. So these are the courses. They do maths, physics, basic electrical electronics. Here also they do maths, physics, basic electrical electronics. I have purposefully highlighted this particular course because this is offered by a computer science engineering department. So they are doing one programming course. Both our EEE students and our ECE students, they are doing one computer science, one programming course. Second semester also, they are doing one computer science course you see here. So they are doing 2 computer science courses in their first year itself. Please remember these things, because when I show you the computer science syllabus, you can easily relate how different we are. Now, similarly, in the third semester, we offer, there are multiple courses we offer. That is, this is related to electrical engineering, electronics engineering, machines, electrical engineering. Electric mechanics is nothing but electromechanics. So electromechanics is nothing but electrical machines. So all the courses are similar for EEE and ECE till third semester. Only in the fourth semester, there will be a slight change here. Please look at these highlighted things, signals and systems. These EEE students also study and ECE students also study. There is a reason why I have highlighted this. Similarly, yeah, in the fourth semester, they do a design course. EEE ECE students also design a course, and even computer science students also design a study design course. So the difference lies here that EEE students do this electromagnetic and instrumentation engineering extra, different course, electrical machine to a different course. Similarly, transmission and distribution a different course. Whereas here, this electromagnetic engineering here and here they are same, analog electronics, analog electronics. Why I'm doing this is because so that I'm trying to relate that EEE and ECE program also varies very lightly, not really large enough. Similarly, the fifth semester courses, you can see the lot of similar courses both the programs are doing. Control systems, digital signal processing, control systems, digital signal processing. In the sixth semester also, they do embedded systems hardware. They do embedded systems hardware and VLSI technologies also. Now, and the seventh semester, it's everything is the same. It is CCC's major electives and major project, CCC, major elective, major project. And eighth semester is also the same. So what you understand from both the EEE and ECE programs is they are almost similar, but with emphasis on certain courses only. Okay, so EEE students also study embedded systems. ECE students also study embedded systems. Likewise, in addition to this, we offer specialization tracks also. EEE students can get a specialization in power systems, power electronics. That is, what does it mean is these are some of the courses that they have to take if they want to earn a specialization in power systems. These are the courses that a student will take if they want to get themselves specialized in power electronics and drives. ECE program, if they want to get a specialization in microelectronics, then they have to do these courses. If they want to get a specialization in wireless communication, then they have to do these courses. Similarly, there are two more specialization tracks for ECE programs. If they want to do specialization tracks in signal processing and computation, they will be doing these set of courses. For RF and microwave specialization, they will do these set of courses. Now coming to the list of elective courses that we offer. You see here that there are a lot of major elective 1, major elective 2, likewise. These are the elective courses which student can choose of their choices, right, in order to get specializations. Now, these are some of the electives for the EEE students. You can see here that they are mix of both EEE as well as ECE students. Digital design using FPGA, this is mostly related to VLSI. Similarly, you have switched mode power converters, photovoltaic power generation. These are some of the electronics based courses. And you can see here that we do offer a computer science based Python Perl script language course for data science and automations also. And we also do give elective courses on VLSI also. Now, I hope you slowly understand that going forward, there are no barrier between a EEE and a ECE courses. Everything is in fact clubbed together and they are overlapping. And you see here that there are a lot of computer science courses which is also overlapping here. Python is a computer science course which is being taught by the electrical faculty, which overlaps with the computer science courses. Similarly, I'm going back to with my slides. Here you see here that these two courses, CSD 101, CSD 201, they are all computer science courses which are taken by the EEE and ECE students. Similarly, signals and systems that you see here is taken by computer science students. Digital electronics that you see here, they are also taken by computer science students. So, overall, you can see that 20% of the courses are very, very similar to what computer science students are taking. So our current EEE and ECE students take 20% of similar computer science students. Now, why we went in for the computer, electrical and computer engineering? The reason behind this, let me erase all these writings. Yeah, the reason behind this, in all the courses that we study, we use computers extensively, either for simulations or to study the software related to it. I will just tick mark those courses where we use computers or we use softwares in order to look at the different applications of computer engineering. For example, in this particular course, we use a software called as Multisim. In again, in semiconductor devices too, they will be doing an extensive laboratory sessions along with some simulations of devices. Here also there is a scope of using multi-sim simulators for semiconductor devices. And yeah, let me erase again. Yeah. So circuitry, digital electronics, they use a microprocessor course. Signals and systems, they use a MATLAB course. Electromechanics, they use a three-dimensional machine design software. Uh, and then analog electronics, they use a multi-sim software. Communication engineering, they use MATLAB software. And in digital signal processing, they use a software. Communication networks, they use software. VLSI, they use software. Embedded systems is a software course. Digital communication is a software course. As I have tick marked multiple courses here, they all have some kind of a software content inside their course. Now, so that is the reason we wanted to move largely towards computer applications, using computers, how the electrical applications can be made. So, and these are some of the major elective courses for ECE programs. You can see microwave. This is again a computer-based course, satellites, digital design using FPGA control system. All these, most of the course, applied machine learning we have here. Again, Python, optical fiber communications, IoT, special topics in RF microwave. All these courses which have an overlapping with computer science engineering program are being taught for our current EEE and ECE programs also. Now we also wanted to look forward. What is this going forward? I mean, in 2011, when SNU was Shiv Nadar University was started, we were the first one to introduce the major and minor programs, which was very much predominant in the US universities. And only after we introduced in 2011, you can see most of the Indian universities also now follows the major minor concepts. Even in the new education policy of Government of India also, they introduce these kind of interdisciplinary and intradisciplinary courses. Now, we also did a benchmarking with the leading other universities also. If you look at the Carnegie Mellon University, they do not have any program like a EEE program or an ECE program. So I'm just opening. Okay? My screen must not be visible. Just a second. Yes. Now you can see that this is. Yeah, this is Carnegie Mellon University's website, and this is for their undergraduate program. The programs that they offer again is electrical and computer engineering. It is not EEE or it is not an ECE program. Similarly, let me take my other example here. The other example, say University of Washington. This is ece.vw.edu, which is University of Washington. This is also, they also offer electrical and computer engineering program. It's not either a EEE program or an ECE program. This is University of Washington for you. And then let me go on to Canadian University, University of Alberta. Yeah, this is U Alberta. They also offer electrical and computer engineering here. This is Department of Electrical and Computer Engineering and University of California, Berkeley. So these are some of the examples. You are very much open to explore more universities also. Again, this is electrical engineering and computer sciences department. So this is how we benchmark ourselves going forward. One thing that we can say for sure is that after 5 years, 10 years, once this particular program is very, very familiarized, there will be many Indian universities who will follow this particular suit of converting this EEE and ECE programs to electrical and computer engineering program. Now, just to give you a snapshot before exactly jumping on to making you understand the electrical and computer engineering. We are establishing in 2022, and this is as per AICTE nomenclature. When we decided that we must do something different with computer applications towards electrical systems, we decided what name we should give to this particular program. We brainstormed multiple ways. Say, for example, we even thought of giving a name like electrical electronics communication and computer engineering program, but that was too lengthy and it might not it might create confusion in the market. So we followed the AICTE nomenclature. In the AICTE nomenclature, we had electrical and computer engineering nomenclature, which we are very much used, and we are very happy to have this particular name for the reason even when your son or daughter completes this particular program and applies for a master's program in US universities, it will be easily recognized instead of EEE or an ECU program. So and why this particular reason we have taken is almost 80% of our students after their BTech degrees here at SNU with our electrical department, they go abroad for their master's program. They do get a job even after doing job for 2-3 years. They again go for a master's program. So when they go for a master's program, for the foreign universities to understand our Indian university nomenclature, electrical and computer engineering suits best, and hence we decided to rename our program as electrical and computer engineering and doing away with EEE and ECE programs. And currently, we offer undergraduate programs, we offer postgraduate and doctoral programs. Postgraduate programs we will be starting sooner, and the professional club that we have is an IEEE club. We currently have I'm speaking currently about the new program, electrical and computer engineering. We are going to offer 4 specializations. There are 13 major core courses here. There are 30 elective courses. There are 10 major elective slots for you. And there are close to 483 students who are currently with us out of 3,308 students. Close to 15% of the population at SNU belongs to the EEE department, our electrical department. We have 18 faculty members, 14 labs, which I have already listed, and more than 80 plus publications we have as in terms of research group. Now coming to our proposed electrical and computer engineering program, which may be of interest to you. You see here that the structure is more or less similar, right? If in case you want to quickly review on our existing structure, I'm just going to the previous slide so that you can relate here. Yeah. Now just remember this particular slide. You have CCC 1818, minimum is 42. This basic sciences is 20, engineering sciences is 12, and then the rest of the elective courses. This particular structure is also very much similar. This structure is also similar. This is CCC is 18, UW is 18, and the minimum credits required is 36. Basic sciences is 20, engineering sciences is 13, and major course is 31. We are offering huge number of elective courses here, which is 32 courses, a mini project and a minor project, close to 9 credits. In addition to this, this is where we are going to be different here. We are going to offer specialization in these 4 different specializations. I said here that we are going to offer 4 specializations here. So the specializations are modern energy systems, analog RF and communication engineering, embedded systems and computer engineering, sensors and nanoelectronics. What does this specialization will add upon is, if say for example, out of the total 160 credits, we have listed certain courses. Out of those courses, if a student is getting 16 credits, then he will be offered these specializations. Now, what does this mean to you as a student and as a parent is, in case this is a sample certificate, right? Your degree certificate now will have obviously the name of the student, the degree of will have these possible combinations. So possible degree nomenclature after 4 years will be either your kid can decide that he wants to get a degree in BTech in electrical and computer engineering. So this is one option. In case a student doesn't want any specialization, right? He takes few courses here, few courses here, few courses here, and few courses here. He will not fulfill these 16 credits, but he can take few credits here, few credits here, few credits here, and then he can just get a degree in BTech in electrical and computer engineering only. Or if he wants to get himself specialized in the first specialization, modern energy systems, then his degree will say BTech electrical and computer engineering with specialization in modern energy systems. Or if he is taking the second specialization, analog RF and communication engineering, then his degree will say BTech in electrical and computer engineering with specialization in analog RF and communication engineering. Likewise for embedded systems and computer, sensors and nanoelectronics. Not only this, now you have seen our structure, UWE, what is this UWE structure, right? University-wide elective. A student has to get 18 credits under this particular category, university-wide elective. If a student from the, we are calling this as an ECU program so that we don't lose this communication aspect here. So if a student goes to any other department and then does certain courses close to 18 credits, then he can get a minor degree. So if a student, I'll just give you more examples also. If a student getting specialized in embedded and systems and computer engineering, he wants, say, he is doing some UWE courses under mechanical engineering, then he will be getting his degree will say that he has got BTech in electrical and computer engineering with specialization in embedded systems and computer engineering with minor in mechanical engineering. Or in case if he is interested in mathematics, if he feels that mathematics will help him grow better in areas of embedded systems and computer engineering, then if he goes to mathematics departments and does certain UWE courses, then he will have a minor in mathematics. So this is how his degree structure will look like. Now let me compare how this particular program and computer science engineering program is different. On your right hand side that you see here are the computer engineering syllabus, and on the left hand side that you see here are the new program syllabus. You can see a very similar kind of a curricula here. We have mathematical methods here, also mathematical methods. We have a physics course. We have a BTech in ECE program, that is basics in electrical and electronics. The same course the computer science students will also be studying here. Introduction to computer programming. Please, here our students will be studying C and C++. And here again, introduction to computer programming, they will be studying C and C++. So the first semester is very much similar. And here also the environmental course here and environmental course here. Coming to second semester, they do mathematics methods. Here also it is mathematics methods too. They are calling it as applied linear algebra. Physics 2, digital electronics. They will be doing the digital electronics here. And then the semiconductor devices course. Instead of semiconductor devices, they are doing material sciences engineering here. So the basics of EEE, anyway, we are offering it for their program. This is for CSE programs. Okay. Now coming to third semester. Mathematics method, they are doing probability and statistics. They will be doing discrete mathematics. We will be doing machines, data structures, and embedded systems, signals and systems. And these students will be doing digital electronics. Obviously, as a first UWE, they will be studying a design program. This design program and this the next is fourth semester ECE's design program are same. Both the courses are same. So we have tick mark, and this computer organization and architecture in computer science, they will be doing here in their fifth semester. So computer organization and design course is already there. And what is the course our students, the new program students will not be doing is they will not be doing object-oriented program. Otherwise, they will also be doing data structures here. They are doing data structures here. So you can see here, all the courses that I have tick marked, the ECE students will also be doing. Going forward, They are doing probability and statistics, and our students have already done probability and statistics here. Signals and systems, our students have already done signals and systems here, right? Similarly, the major elective course and UWE courses, they are very, very similar. They are doing an artificial intelligence course. I will show you where our students will be doing an artificial intelligence. So, and these courses, they will, our EC new program students will not be doing. They will not do operating systems. These highlighted red programs, they will not be doing. Software design lab, design and analysis of algorithms, introduction to database. And they are doing the major elective. Please remember one thing that you can relate here is both both this ECE program and computer science engineering program. So this is the CSE program. They are doing only one programming course, which is nothing but the C programming. Here also they are doing one C programming course only. Now, here, as you see here the students are doing artificial intelligence, right? The same artificial intelligence, our computer science students will, our ECE students will also be doing in their 6th semester. Computer networks is very, very similar to what the computer communication networks our students will be doing. And the highlighted red courses is the courses our students will not be doing. So now I have compared you 6 semesters of courses where 3, 4 and just 5, 6 courses, they are very, very different from what the existing computer science engineering courses are doing. And similarly, our 7th semester will be same, major elective 6, 7, 8, major elective 5, 6 and some UWEs there. And these are some of the elective courses that they can choose for this. I'll come back to this particular part. And final semester, it is the project semester for us also, for computer science also, for ECE also. Now coming to the specialization track. I said here in the first slide that, in this slide, that they can get specialization in modern energy systems, analog RF and communication, embedded systems and computer, sensors and nanoelectronics. How do they earn this? How do they earn this is, you see here that we have listed a lot of courses here, right? These are elective courses. These are some of the elective courses. Similarly, these are some of the elective courses. And these are some of the elective courses. Now, if you want to earn a modern energy systems specialization, then you have to choose out of these 8 courses that are listed, they have to just do 20 credits of courses. As you see here, it must have been written 16 credits from a particular specialization is required. So there are total 26 credits. They have to do any course that is on offer. You can see, say for example, let me take high voltage engineering, right? This is offered in 7th semester. Where is 7th semester? This is the 7th semester course. And high voltage engineering will be offered here. So which means as part of any of these 3 courses, this high voltage engineering will be offered. If they take it and if they fulfill 16 credits from this bucket of courses, then they can earn modern energy systems as a specialization. Similarly, if they want to get specialized in analog RF and communication, the bucket is very, very large here. Out of 49 credits, they just have to take 16 credits. Similarly, out of 19 credits here, they are going to take only 16 credits. So for embedded systems and computer engineering, please note that this particular list of courses is bound to increase. Only yesterday, we had spoken with ST Microelectronics, which is a very huge industry, chip manufacturing industry, which is located in Greater Noida, where they are very much offered to teach us a lot of VLSI based courses and IoT based courses and computer science based courses. So this particular list is bound to go large. And for specialization in sensors and nanoelectronics, they have to do these courses: VLSI, sensors, digital design, WBG devices, and analog CMOS devices. So this is how the specializations are. And just to give you a brief overlook on what computer science is doing. So this is the structure of computer science also. Because in case you are more interested in computer science and you will not do anything else, so just give you a they are also want 18 to 24 for CCC, UWE 18 to 24, basic science is 17, engineering science is 17, major core is 61, and they are offering these specializations. artificial intelligence and machine learning. Even our current ECE Pro students will also be getting the same kind of specializations. They are offering data sciences and big data analytics as additional specialization, cyber security and privacy as additional courses. So with this, I hope I have made things clearer for electrical and computer engineering courses. If you have any questions, I'll be happy to answer.